Another example, a 1.5 meter diameter vertical cylindrical trunk, 3 meters high, contains 2.5 meters of water. 100 mm diameter circular sharp edge orifice is located at the bottom with a coefficient of discharge of 0.6. How long will it take to lower the water level to 1.5 meter deep after the opening of the orifice? Okay, so here is the orifice. So what is the time required for the water inside the tank, which is 2.5 meter in depth, to be lowered to a depth of 1 meter? So since this is cylindrical, it means that the surface area or the cross-sectional area are constant along the cylinder. So we use the solution T equals to 2A S over CA, the square root of 2G, times H of 1, square root of H of 1, minus square root of H of 2. So H1 here is 2.5 meters, the initial depth of the liquid. So for letter A, our H2 is 1 meter. Okay. So the surface area of the liquid is, we have 1.5 meter diameter. So we compute that AS equals to pi d squared over 4. One 1.767 square meter. So T equals to 1.767 over C 0.6. Okay. So AO is area of the orifice. So we have diameter of 100 mm. So we substitute that. That's 0.1 meter raised to 2 over 4 multiplied by square root of 2g, 9.81 meter per second squared, times the square root of h1. h1 is 2.5 meters minus the square root of 1 meter. So let's compute that directly. We have an answer of okay, multiplied by square root of 2.5 h1 minus square root of 1. Okay, so the answer is 98.39. That's in seconds. 391 seconds. So this is the answer for the time for letter A. For letter B, uh, how long will it take to empty the tank? So initially at 2.5 meter depth. So if the tank will be empty, it means that our H, which is measured from the opening of the orifice, is 0. So for letter B, H2 is 0. So same solution, only that the H2 is 0. So same, 2 times 1.767 over 0.6 multiplied by pi 0.1 squared over 4 times 2 the square root of 9.81, then multiplied by the square root of 2.5 minus square root of 0. Okay, just change this to 0. So the answer for the time required to empty the tank is 267.69 9 8 seconds. Okay. So that's the answer for this problem. Next. Another problem, an open cylindrical tank 4 meters in diameter and 10 meters high contains 6 meters of water and 4 meters of oil. Find the time to empty the tank through a 100 mm diameter orifice at the bottom. Given are the coefficient of contraction and velocity. Okay, so let's solve this. We have a general solution of T equals to 2as over Ca square root of 2g multiplied by the square root of h1 minus square root of h2. So if the container is prismatic, we can use this solution. But in this problem, we have two types of liquid. We have water and oil. So for us to compute the total time to empty this tank, we have to compute the total time for the water to spill out on this container. Then we add the total time for the oil. Okay, because the water will first come out. Then after all the water is removed on the container, what remains is the oil, and the oil will also come out on this orifice. So we will compute them separately for the total time for the water and for the total time for the oil. So using this equation, okay, what will vary here is the height that we are going to use. So in the water, for the total time for the water come out in this container is that our h1, okay, h1 or the initial depth of the liquid shall be measured from the opening of the orifice up to the uppermost portion of the total contained liquid, because this oil above the water is also it contributes to the amount of water or the pressure of the water that will come out of this orifice. So it is also considered in computing the total time for water. So for our H1, so we will include the equivalent head of the oil to the total height of water, which is 6 meters. But since this is the equivalent head for the oil, we need to convert it into equivalent head of water. Okay, so this 4 meters depth here of the oil should be converted, okay, to equivalent head of water. So again, we multiply it to the ratio of its specific gravity to the specific gravity of water, which is 1. So it means that our H1 here is equals to 6 plus 4 multiplied by 0.8. So that's 9.2 meters. It means that's the equivalent pressure head from the opening of the orifice at the initial position, or when the container is filled with water and oil. So we have a total equivalent head of 9.2 meters. So our H2 is when all of the water is spilled out, which means that this 6 meters here 6-meter height of water is removed. So it means that the remaining height should be this 4 meters, but you have to convert it into the equivalent head of water, which is this one. So it means that the H2 here is 4 times 0.8, that's 3.2 meters. Now, for the total time for water, that's 2 times area of the surface. Okay, we have 4 meters diameter. Okay, so surface area, that's pi d squared over 4, and area of the orifice, pi d squared over 4 also. So pi over 4 is cancelled out, so I'll just substitute here the diameter squared of the surface or cross section of the container, which is 4 meters, raised to 2 over c. So I don't have a value for c yet. C is cc times cv, 0.9 times 0.98. So the coefficient of discharge is equals to 0.9 times 0.98, 0.882. So this 0.882 times the area. So as I've said earlier, pi over 4 is cancelled out. The diameter squared, 100. So that's 0.1 meter squared times the square root of 2 times 9.81 meter per second squared. Then multiply square root of h1, 9.2 meters, minus the square root of 3.2 meters for h2. So the total time for water is 2 times 4 squared is 16, 0.882. Okay, so this is total time, 1019.191 seconds. So, after the water is spilled out on this container, so the remaining liquid is the oil. So we will use again this solution. Okay, T equals to AS over CA square root of 2G times the square root of H1 minus H2. For the oil, our H1 is, so since the remaining liquid is oil, we can now use its height. Okay, its head, which is 4 meters, and H2 is 0. So for the water, since initially we have two liquids still present on the container, we have to convert either one of the two liquids into the other. But of course, on what liquid that is in the opening, since water is at the opening of the container, which is coming out of this container, so it means that oil should be converted into water, into equivalent head of water. Then when all of the water came out, so this oil here is already here, which have a height of 4 meters. So the liquid that is in contact with the orifice is now oil. So we can now use the height 4 meters for H of 1. So using again the same solution, we have total time for the oil. Okay, total time for the oil equals to same values, 2 times 4 squared over 0.882, 0.1, square root of 2 times 9.81 multiplied by square root of 4 minus square root of 0. Okay, square root of 0 is 0. This is 4, so just change this to 4. The answer is 1638.181 seconds. Then add the 2, total time 1019.191 plus 1638.181. Total time is equals to 2657.372 seconds. Okay, or in minutes divided by 60, that's 44.29 minutes. Okay, so this is the answer. Next problem. So last example. The rectangular tank shown is divided by a partition into two chambers and provided with a round 150 mm diameter sharp edge orifice right here. At a certain instant, the level in chamber B is 2 meters higher. Okay, these are the initial liquid level. Then how long will it take for the water surfaces in the two chambers to be of the same level? Okay, let's say this is the final level of the two liquids in both chambers, of the liquid in both chambers. Okay, assume C is 0.62. So since the cross section of each chamber is rectangular, they are prismatic, we can directly solve this using the solution AS1. Let's say AS at chamber A, AS chamber B, area of the surface area over surface area at A plus surface area at B multiplied by 2 over CA area of orifice square root of 2G multiplied by square root of H1 minus square root of H2. So what are the surface area? They are rectangular shape. So surface area at A, that's the dimensions are 2 by 3. So 2 times 3, 6 square meter. Surface area at B, 2 meter by 7.5. That's 15. Okay. For H1 and H2, H1 we have 3 meters and H2 is 0 because they are in the same level. Okay. So 6 square meter by 15 divided by 6 meter square plus 15 square meter times 2 over C is 0.62, area of orifice 0.15 mm diameter multiplied by the square root of 2G, 2 times 9.81 meter per second squared multiplied by square root of H1, 3 meters, and 0 or square root of 0 for the final difference in height of the liquid surface at both chambers. So let's compute this now. Okay, so 6 times 15, 6 plus 15 times 2 over 0.62 times square root of 3. Okay. The answer is 305.915 seconds. Okay. That's the answer of this problem. Okay. That ends this lecture, this part of this lecture. God bless.